Hello, today my name is Aditya Bagaria and I'm here with Avnish Rai and we're going to present our project on PFA, that is Programming for Analytics. So what we did over here was we took the AQI data for 5 cities, that is Beijing, Sydney, London, Mumbai, and New York, and we are going to compare the live AQI data and the historical AQI data, and we're going to do some analysis based on that. So what type of data we are using? We are using air quality index. We are using hourly concentration of air pollutants, the different air pollutants like carbon monoxide, nitrogen dioxide, sulfur dioxide, and ozone. And we are having geographical coordinates for each city so that we can plot the cities on the map. So what are we doing with this data? We are retrieving the current AQI and then creating a bar chart. Then we are retrieving the latitude and longitude to create a map where we mark the locations and we'll display the AQI on the map for each city. Then we are retrieving hourly data so that we can create certain plots like correlation, heat maps, box plots, and pie charts to get the detailed analysis for each pollutant and the AQI of the city. So what type of analysis we are conducting? We are conducting descriptive analysis, comparative analysis, correlation analysis, time series analysis, and spatial analysis. We have adopted our source code from here. Here's the link, which will be available in the readme.md file. So we have taken two API, that is one Open Metro and WAQI. So in using the Open Metro, we are getting the historical data for the last 24 hours and more for a particular city. And using the WAQI, we are getting the live AQI data and the pollutants that are present in the air at the current moment. The last reading that was taken a few hours ago or a few minutes ago by that particular location is updated in WAQI, and we are using that data to generate the maps. We are using OpenMetro to do a descriptive analysis for the last 24 hours and even more at times. So the motivation behind this project was to raise awareness about the air quality issues in the big cities around the world. This project will will use some visualization tools to demonstrate the severity of air pollution in different parts of the world and attention to the need for air quality management and public health intervention. I've also mentioned my API key over here to generate the live data. So where we are using 5 different libraries. So if you are running this code on Anaconda, Spider that is, you have to use conda install and the library name if you are getting a library error. So we have used request pandas, matlib.pyplot, cbond, and cartopy.crs. So first we find the data that is how good the data is from Open Metro and WAQI API. We generate the output for both of them just to see what kind of data we have. So over here we have time and the AQI. So the historical data is present over here, the different time slots and the corresponding AQI taken at that time. The non values are for the future time, the data that has not been taken yet for a particular day. So this is for 5th of, 17 to 21st of June that you can see. And we have the live data here. So over here we get the different values like carbon monoxide, DU value, NO2 value, ozone value. So for this project, we have taken CO, NO2, O3, and SO2 value. From here, Avnish will take over.
So now, as you can see, we are defining which cities are we going to take from the data. So we have selected Mumbai, London, New York, Beijing, and Sydney. We are passing as a list, and then using this URL, the data will be created, and this will be get appended for each of the iterations. So here, as you can see, go down. Finally, we are using the data which we have created, and we are plotting the AQI. On the x-axis, we have the location of the cities, and on the y-axis, we have the AQI. So if you see that Beijing has the highest AQI as compared to the rest of the cities, we can get this visual data like an on-time data every time we run the program. Okay. Now going to the fifth step. Okay. So here we are visualizing the live location of the data using the code. Go above little bit. for the code. So we are using the matplotlib, the plot.figure functions, and we are getting the city's location based on the URL, and we are using the geoplot location, uh, this library, to get the location of each cities. So our output is shown below. So here we have the London, New York, Mumbai, Beijing, and Sydney. We can create for the rest of the city, like whichever the city we want to, and we just have to append the name of the city in the city list, and use run the code. This will give the location of that particular city also.
So that is what we did with the live data. Now to deal with the historical data, we are using Open Metro API, like I said. And for that, we need the latitude and longitude values, which we generated when we were plotting this map. So after getting the latitude and longitude data, we put in the values in the link, and we try to create a list with different cities, the URL, and then the data is generated for the time and the US AQI. So moving on with our first plot, the first plot is a line plot where we have taken hourly AQI of the selected cities, and on the x-axis we have the time for that particular day, and on the y-axis we have AQI, and then we can see that how the AQI pattern is changing throughout the day for different cities. Over here we have the legend where we have different cities marked with different colors, and over here we have the line chart. As we can see, in general, Beijing has a really high AQI throughout the day, and we can see that uh, Mumbai has a pretty flat AQI throughout the day, that is between 60 and 80. Okay, we then proceed to make a correlation matrix. We create a heat map of correlation matrix for different parameters, that is carbon monoxide, nitrogen dioxide, ozone, and AQI. And we try to find out if there's some correlation between different parameters, and if there is a correlation, what is the value of that relation. So here's the generated chart for each city: Sydney, Mumbai, New York, London, and Beijing. So I'll just take Beijing for a reference. So over here we can see the carbon monoxide value is highly related to nitrogen dioxide value, which is 0.88. And for AQI, we can see that the biggest contributor to this is nitrogen dioxide itself, with 0.4 as the value. We then generate a table to show the time of the day with the highest and lowest AQI for each city. So here's the list of the city, the time at which the AQI was maximum, and the time at which the AQI was minimum. For that, we have created a table in which we have appended the data from the list that we created earlier, the data that we generated earlier, and we found the maximum value of the data and the minimum value of that data for that particular city, and we found the reference time for that particular data, and we generated this table. We then proceeded to create a box plot for each city to study the AQI distribution over time. So as you can see the box plot, here's the mean for each city at that particular hour of the day. There are 24 plots over here, 24 boxes over here. And for each city, for New York, I'm going to take it as a reference. So for the first hour, that is between 12 o'clock in the night and 1 o'clock in the night, the data ranged from 55 to between 35 and 40. And the mean value was somewhere around 40 to 45. I'm going to say 44 over here. And this is how we read the box chart, and we get a pattern over here, how the data how the reading has changed throughout the day, and what was the variability in the reading throughout the day. So here it is for each and every city. Okay, we then generate a AQI heat map for each city to see how the data changes over time. So here's the code for that. So as you can see, London has a pretty low AQI throughout, and Beijing has pretty high during the early hour of the day as compared to, and it keeps going down towards the later hour of the day. And Sydney goes through the same. It's a little high for Sydney, somewhere around 60. Mumbai, like I said, is pretty much between 60 and 80. So this is how we're going to read this. Then we finally generate a pie chart plot for each city to view the individual parameters and their percentage in the air for that city. So we have taken 4 parameters into consideration: carbon monoxide, nitrogen dioxide, sulfur dioxide, and ozone. So for each city, we have created a pie plot over here. And for Sydney, we can see the carbon monoxide constitutes of 68.8% of the entire air, the pollutants that are present in the air. The ozone is constituting to 17.7%. Nitrogen dioxide is 10.7%, and sulfur dioxide is 2.8%. Similarly, we have done it for every city, just to take one example. And as we know, carbon monoxide is a very harmful gas, and we saw that in Beijing, the carbon monoxide was maximum. Even the correlation said that carbon monoxide is highly related to AQI, and that's why we are suggesting that the Beijing has the highest AQI level. The air quality index is very poor because of the presence of this particular toxic gas out there, which is carbon monoxide. So this was our project, our PFC project for the AQI reading of different cities. And yeah, thank you for watching.
Thank you.